Okay. Good afternoon. My name is Tristan. I recently joined Axiogenesis, and hopefully to speak to you briefly about our human cardiomyocytes and neurons, which are derived from stem cells. We're on booth A5 today with my colleague Geza. So a little bit about Axiogenesis. We are based in Cologne. We've been going for 15 years almost. It's quite mature for a stem cell company. And we were the first to release a commercial model of stem cell-derived primary-like cells for drug testing and use for toxicology. We have 30 full-time staff, and most of us are PhD and hands-on in the lab some way or the other. And we have a global distribution network with facilities in Cologne, but also on the west coast of the USA. And this allows us to actually provide fresh cells pre-plated anywhere in the world. So a little bit more about what we actually do. We're the first to license the Yamanaka protocols in Europe for producing iPS cells, and we have our own line, and produced first cardiomyocytes from them. They're high quality, consistent, and 100% pure. We don't use cytostatic compounds in our media. Once you receive cells for your use, they're well characterized for safety and pharmacology, actively used by a number of high-profile academic and pharmaceutical groups. We come in cryopreserved formats, so whether you're patch clamping, you want small amounts, up to the high throughput system, say your calcium transients, analyzing large libraries, and again, the fresh pre-plated cells. So, for example, in a 384 well or a 96 well ready to go, within a few hours of receipt in an incubator, the cells will start beating again. Maybe in as little as 2 days, application dependent, they're ready to load up and start testing compounds on. And this really makes us novel and stand out, I think. And we have regular or serum-free media, depending on if there's interaction. So we continue to innovate, and I think one of the important things we have alongside that is a cardiac fibroblast derived from iPSC. And of course, iPSC, you can go and produce unlimited amounts of cells, and you can come back to the same cell source. And why is this important? Because 70% of the heart is fibroblast in nature. And there are compounds that only attack or only affect the electrocompetent fibroblasts. These are electrocompetent. If you have dispersed colonies of myocytes, you will get synchronous beating of the whole well. And this is obviously more physiologically relevant. It allows 3D culture, which is obviously everybody's moving to, but also the mix has a notable effect on the maturity and how cardiomyocytes respond. So we've recently launched our peripheral and dopaminergic neurons. Again, they respond in the typical ways as primary-like cells. They're patch clamped, they show the relevant channels, spontaneous electric reactivity on MEAs, calcium transients. We've got a number of groups already using them for toxin replacements, so replacing mouse models with physiologically relevant cells, and, for example, neurite group outgrowth and the typical staining of the antibodies and the proteins you would expect. So obviously at Axiogenesis we realized to commercialize these cells and not just say we are a cell provider, you need to provide protocols to facilitate the introduction into labs. So we stand and routinely use for at least 10 years the microelectric array, the impedance methods, and calcium transients. We work with a number of vendors, not limited to those up there, and are more than happy to take work in as a service provider, but also run validations. We've taken blinded compound studies and been able to get significant information back for the customer. And so, thank you. To briefly outline what we do and where we are, and we're at booth A5, and we have a couple of posters. Thank you.